Let's talk about XSLT, right? So XSLT um, is it stands for Extensible Style Sheet Language, right? Transformation. It's a mechanism that allows you to transform XML documents that might meet a particular schema, transform them into some other XML document, right? And as I mentioned earlier, it's often the case that that these XML documents are being shared amongst multiple vendors, multiple enterprises, right? Different companies, either because they're in business together, or they might have been merged, right? Acquisitions amongst several many years, and you have all these documents flying across the network that, but one of them might have started with MySQL and had a very normalized representation of the data, whereas some other folks might have a SQL Server and their data is not as normalized, right? And they might have different representations of clients and products and even though they might conceptually mean the same thing, right? Their representations is different. So it's oftentimes the case that at the endpoint of interface between these two worlds, right? You'll send me an XML document that has information that the information that I want, but it's not in the format that I need it. All right, it's not, the fields are wrong, they're nested in the wrong order and whatnot, and oftentimes I need to be able to transform one representation into some other representation. So XML provides very, very strong support for converting different representations of XML documents in between them, right? So here's an example of what we had earlier. So we had a graduation students of a list of students. Presumably this will be a long list of students, each one with names and courses that they've gone through and whatnot. And perhaps this might be a little bit too normalized, perhaps, right? Very much like when we looked at in relational databases, and we were trying to, first we looked at finding the best normalized implementation, right? We broke it up into a whole bunch of tables. Yes, here's the sections and the courses and the departments and the enrollments and the students and whatnot. It was the best way that we could normalize it, right? It met first, second, and third normal form, blah blah blah. But then different users wanted to consume the data differently, right? And so what we did is that instead of messing around with the nicely normalized representation, what we did is that we created a different representation using views, right? And that view might have been joins across multiple multiple tables, provided a denormalized view, right? Denormalized representation of that data, only because it was more convenient to consume that data in a denormalized fashion, right? Perhaps this was a registrar's office or admissions, and they wanted to be able to grab some information from the students and some from the departments and from different tables and have it in one denormalized representation. Yes, this allowed us to keep the normalized representation, but then have a denormalized view on it. Yes. So same thing here. We like to be able to convert or transform, right, one representation of the data into some other representation, right? And XSLT is going to allow us to do that, right? It might be that we don't need this very normalized representation. We need something more flat, okay? That grabs information from different sections of the document and provide us with a much more flat representation. Maybe I want all the courses, right? Not so much about the students, but I'm more interested about the courses. I need to be able to iterate over all the courses across multiple students, yes, and extract all the courses. And maybe I want it the other way around. Instead of students containing courses, I like to represent it backwards. I like to see all the courses, right, and see which students are in that course. Yes, so I don't have that here, right? I need to be able to transform it, right? So XSLT allows us to do that. So XSLT transformations are written in XML, right? So the transformations themselves are also written in XML, but whereas an XML document typically just contains data, right? Passive data, XSLT are meant to be executable, right? They're meant to be run by some algorithm that parses the XSLT right? And then it performs the transformations, right? It says, okay, well, I want to apply this transformation and transform this incoming XML document, run it through my transformation, and then it'll produce another XML document. Yes? Which will make it flatter or more normalized or less normalized or whatever. It'll extract certain things. Okay. So in that sense, XSLT are more or less the equivalent of a view, right? That the view is performs a well, maybe it's a view with a store procedure, maybe, because you can also do for loops, and you can do groupings, and you can do all sorts of very powerful almost like functional programming. Okay, so yeah, so they're more like a combination of store procedures, with select statements in there. Okay. All right. So also here, notice that the element here is it's called style sheet. See that style sheet? It has an opening tag, and here you have the closing tag down here. See that? But notice that you have an XSL colon in front of it. See that? Right? So XML also allows you to qualify your element and say, how should I interpret this element? Style sheet. Okay, that's very important, since allows you to namespace your elements, allows you to provide the mechanisms that we all take for granted. For instance, in Java, we have packages, yes, and packages allow you to namespace your classes. It allows you to break it up into a specific context. Right? Perhaps one package or the package name might have a class name called table, right? And in some other package, you might have the same class name, also called table, but it's a different package. Yes? And the two tables might mean two completely different things. One might mean, maybe it maps to some Excel table. Yes? Whereas the other table might map to some HTML rendering of a table, right? Completely two different contexts. Yes? Right? And that's why we have naming, right? That's why we have packages, because we can have different meanings. So same thing, XML provides also namespaces, right? So that your elements can have maybe the same element name, but under a different namespace, right? And so even though they might have the same name, the same element name, they might mean completely two different things, right? So here, style sheet belongs to the XSL namespace, and XSL is a very well-known namespace, right? Maybe like Amazon.com is a very well-known domain, yes? And so you would not name your packages as com.amazon, because that domain doesn't belong to you. It belongs to someone else. You would use your own domain names, yes? So same thing, XSL is a very well-known namespace, right? That belongs to w3 w3.org something XSL, okay? That declares a certain vocabulary of elements, right, that have a meaning under that package, under that domain. Make sense? Same thing like in Java, you might have under a package, you might have several classes in there, and it has a meaning under that particular package. Right? Same thing here. Anyway, we're declaring the namespace, and it belongs to those folks, the w3.org. Also, style sheets has a different versioning. We're up to 2.2.0, latest. And so in that namespace, we have all sorts of elements that are specific to the process of converting one XML document into another XML document. Okay. Now, if you've used anybody have done CSS and HTML, so CSS is somewhat an equivalent to this, right? CSS is a watered down version of this, right? What does CSS do? CSS, or cascading style sheets, right, allow you to refer to different elements in the HTML document and say, hey, see that element over there? It's rendering white. Well, I want to change it to blue. Okay, it allows you to say, hey, it has two pieces, right? One of them is what I call the selector, right? It allows you to refer to the document and say, hey, see that paragraph over there, right? Grab it And then the second part tells you what do you want to do with that element, right? Oh, I want to turn it blue, right? The foreground to be white and the background to be blue and the font to be, whatever. Yes, okay. So that is a watered down version of this concept. There is a selector that allows you to refer to the document, and then there is a transformation. What do you want to do with that element? Once I find it, what do you want me to do with it? You want to remove it, right? You want me to hide it? You want me to make it big, small? What do you want me to do with it, right? And then the result is what you see rendered on the screen, right? Here, you have an incoming XML document. Then you have the XSLT that says, hey, all these courses elements, right? I want to group them. I want to iterate over them. I want to add another attribute. I want to add another elements in there, right? And then the resulting XML, right, is the output. Make sense? Okay. So the way we capture, or the way we refer to the incoming XML document is through what is called a template. So template allow you to provide incoming matching rules, right? These matching rules, right, that allow you to say, hey, match the incoming XML document, look for these elements in the incoming XML document, and here's what I want you to do once it matches, right? So notice it says match. See that? It says that this template will execute, right, will apply if there is a matching in the incoming XML document, right? If there's a node called graduating students, and actually there is, right? There is indeed, the root is called graduating students. See that? So the parser is going to parse this, it's going to try and match it with the templates. Once it finds a matching template, it says, okay, what do you want me to do with it? Okay. All right, so we have that template here that it found it. It matched graduating students. Here we have another template that matches the student elements, right? This is the equivalent in CSS where you have a heading one or a P or an UL or right, and they match elements in the document, right? So those are the templates. Okay? Now, so we saw the left-hand side of the CSS. Then inside of the templates, you can provide the transformation. What do you want me to do? Do you want me to? You can replace the entire original content, and you can generate new content. Right here, we're saying matches graduating students. Whatever you find that, generate the following. Right. Notice it says student names. See that? So meaning that the graduating students, right? The output is going to take the input graduating students. The output that is going to be generated instead is going to say student names. Student names. Okay. And in there, we're going to say, okay, once you've generated the output student names, you're going to now apply the template that is down below that matches student. Right. So it triggers the template that is down below. Right. And that's going to match all the student elements in the incoming. So whatever this matches, right, it's going to be whatever this generates is going to be generated inside of the output student names. Right, it's going to be applied and put it in there. So what it's going to do for each student, what it's doing here is that I'm losing my voice. Excuse me. Am I yelling? I think I'm yelling. So as I was saying here, the student that it matches. So when it matches the student here, right, when it matches it, what it's going to do, it's going to generate inside of the student names, it's going to generate for every student that matches, there's a whole bunch of students, it could be thousands of students, right? And for every student that it matches, this is going to execute, right? It's going to generate name, right, a name. And inside of name, it's going to add the value of select S name. So S name is an element inside of the student, right? Right. It's going to grab it, right? It's going to grab the value, meaning the string value of that element, and it's going to insert it in here, right? So the output from this incoming XML document, generates the following. As an output, it'll be student names, and only the name, right, has been extracted. So it completely ignored the courses, completely ignored the graduation year, the grade, any of that, right? That's it only extracted the names and it put it inside of the encompassing student names, right? So this is perhaps a much more flat, right? It's like a view, right? I only cared about the student names. It could be like a select, right? And it retrieves it, and then it can transform all those documents into this output. All right, so this representation here, this implementation here is oftentimes referred to as a rule-driven engine, right? Notice that there's no explicit indication of how the order in which these things execute, right? There's no explicit order in which we say when these things should happen, right? It's somewhat more like a recursion, right? That how these things happen. So some folks are taken aback from using this implementation, but worry not. There is instead an alternative implementation that uses an iterative approach as opposed to a recursive approach. Okay, instead of creating these templates, nested templates that trigger each other, right? Instead, you can use a for loop. You can use a for loop. You can say match the graduating students, right? When it matches, which is there's only one graduating student, so there's only one student names that gets generated as an output, right? Then it says, okay, I'm going to match the student elements inside of graduating students, and for every one that I find, I'm going to create a collection of all those nodes. I'm going to iterate over them. So here I'm going to do a for each of the students that match, and as I'm iterating, I'm generating an output, a name element. I'm generating a name element, and for each one, I'm just retrieving the value of the S name, the student name. So this is an equivalent implementation of the previous one. One is a more recursive implementation or rule-based implementation, whereas this one is a more iterative implementation. And some folks prefer this mechanism instead. Yes, but they're totally equivalent.